Yeah, so I'm Eric Dalstrom. So what I wanted to talk about was the history of the early space stations. And I'll leave this as I'll ask you in a few minutes how many earlier space stations you think there were that were launched on orbit, occupied, and then deorbited. Then I'll talk about the International Space Station, how I was involved in the early design of that. And then talk about the 4 commercial space stations that are under construction right now. And then I'll give you some wild ideas about future destinations to space. The main message here is that we're in a transition from government led space stations to commercial space stations, and we're starting to see it connect into commercial transportation. So my background, I started in physics and astronomy and then went into space engineering and worked on space station design for about 8 years as a contractor to NASA. My wife and I, Emmeline, started Space Base, moved to New Zealand to support the space industry in New Zealand. And just recently, we're working on connecting a global network of similar organizations around the world. So more about my background, because I came from the physics background, they didn't know what to do with me at NASA. And so I looked into having an open charter to look at any aspect of the design. So the NASA Langley Space Station office was a technical advice to NASA headquarters. And we had the office could look at any aspect of the design. We had specialists in all the different subsystems. And I was involved with looking at configuration options, user accommodations, flight attitude, communication power, orbital debris, orbital analysis, and early design connections with the Russians. So we went through a whole series of 5 redesigns, a shrinking space station, and at the same time that our exploration office was looking at expanding it to assemble lunar vehicles and things like that. So we were dreaming of it getting really big. At the same time, we were working on making it smaller. One area that I worked on was some of the early conceptual design of the pressurized mating adapter connecting the US and Russian parts. And for this Lego model, it is literally the smallest piece. It's like, look, Mom, this is what I've been working on. So it is the tiniest part of the space station, but it's like a plug adapter that you crawl through. So this is generally what I'm wanting to talk about was the current government-sponsored space stations, the International Space Station and the Chinese Tiangong-3. And then there's a planned government space station, Lunar Gateway, and then there's planned commercial space stations with all these different companies trying different approaches of building space stations. The big question is, they're all trying for the market of taking over NASA contracts and international partner contracts for operations at the same time as looking for markets in manufacturing on orbit and also space tourism. So, and in the bigger scheme of things, I think there's an opportunity to connect into the global transportation network. So, who would like to guess how many former previous space stations? 4. 4. Okay. Any other guesses? 8. 8. Okay. Any other? 6. 6. Okay. Answer is 10. So there is a whole series of Soviet and Russian space stations. There's the US Skylab, and there's also 2 Chinese space stations that have been deorbited. So I will jump this video. We'll see if it plays. No. Okay, now the next question is, will I be able to advance? No. Okay. go to backup. Let me switch over to the PDF. So let me stop sharing that and share the other PDF when I get that running. And let's see. Can you help me get the share correct?
I was just sharing the screen.
Oh, you were just sharing the screen. I should have kept it that way.
No, that's all right. Let's share screen.
Okay, then now I can make this larger. Okay, so the Soviet Union and started with this Salyut 1 first space station, and that was they had a crew there for 20 days, and unfortunately the crew died on reentry. The valves opened and they were exposed to vacuum. They couldn't close the valve, and they died on reentry. They did continue on with a whole series of Salyut space stations. It was a little bit, they were trying to disguise the fact that some of them were military and different design. But basically they were experimenting whether or not, basically astronauts or cosmonauts with binoculars, if they could play a military role, and they finally decided they couldn't. All they could do was find the Sixth Fleet in the Pacific, and that's about it. Skylab was right at the end of the Apollo program, using an upper stage from the Saturn V. It was a huge facility. You can notice that one of the solar rays ripped off when they launch, and also the insulation. They had to do a rescue mission of trying to keep it from overheating. And then Salyut 6 and 7. The Russians were demonstrating long duration missions. They had a year on orbit. They had about 43 visiting cosmonauts for these space stations. Let me keep on going here. With Mir was the multi-module station with different laboratories, and they ended up having 125 cosmonauts and astronauts visit Mir. Mir had a tremendous amount of experience over 15 years or so. They also had a robot vehicle run into one module and puncture it. They had a fire on board. They had all sorts of lessons about life support and long duration. So way back in '86, I crossed the Iron Curtain and visited Prague to talk to the Czech and Russian proposing a shuttle visit to Mir station, and got into all sorts of games with Czech, Russian intelligence, CIA, and FBI. And so I got an FBI file, and that blocked my astronaut application just after that. The astronauts that were selected were on a shuttle visiting the Mir space station. So my timing was absolutely terrible. But I was working with the people that ended up negotiating the deal for Russia to come into the ISS. And there's some pictures of Skylab with a big interior with 6 meter, almost 7 meter diameter interior. They had lots of lessons about the astronauts really were upset that they were being scheduled every 15 minutes for 3 months. And so they went on strike at one point, saying that they wouldn't be scheduled by a room full of 100 people at that level. The Russians had already learned that they give cosmonauts a weekend off and things like that. The Chinese sort of replicated the early days of the Russian program with a few small stations, and with improved technology, they basically copy and improve. It's a good design. But the current Chinese space station is very similar to Mir, except it flies like the International Space Station, flies oriented towards the Earth, whereas Mir was mainly oriented towards the sun. And so the Chinese are about to launch their equivalent of the Hubble telescope that actually docks to their station and then separates off to do operations. So it's a very modern design. So getting to the International Space Station, in the early days, well, here's some of the factors that if I was giving a course, I would go into these different things, but the many of these things are very similar to aircraft design. It's only some aspects that are specific for space. I'll mention a few as I go along with the orientation and orbital aspects. So that when the space station program was first announced, it was each NASA center proposed its own design, and the one in Texas was proposing one that was focused on crew and interior operations. The one in Alabama was focused on attached payloads, looking up, looking down. The one at NASA Langley was this power tower, which had the big rotating solar rays tracking the sun. And in this case, the modules, it was a gravity gradient orientation where the mass of the modules is away from the center mass and ended up helping stabilize the space station oriented towards the Earth. The problem was that the modules were away from the center mass, and so the microgravity wasn't ideal inside the labs. So, but my boss at Langley always loved the power tower. And whenever we changed it, he would always show that he really loved it and we should go back to the power tower. So the dual keel was after NASA Langley demonstrated you could assemble this truss structure that almost the size of the vehicle assembly building or the sky tower or something like that. But it's with these big trusses that held attached payloads for looking into the sky or down to Earth. The problem was that you could assemble that, but then you had to lay out the power and thermal and data lines, and that took maybe 500 hours of EVA time. And so we had to back away from that. But you can begin to see how the modules are proposed to be connected. The European and Japanese stuck out there. The truss structure was changed to integrated truss, that was packaged before launch. And at this low extreme budget cut one, we couldn't even afford the fourth array to make it symmetrical. So it was looking like this. And the other proposals for how to save money were extreme. There was one from in Houston that was saying, why don't we just launch Columbia and stick some solar arrays on it and leave it on orbit? And our colleagues at NASA Langley were making fun of them by showing this comic. It was everybody looked at us in horror about, especially the international partners who were like, you want us to stick on our modules on that? So this is when the Russians came in. The Russians took their Mir 2 space station and proposed adding it to combining it with this International Space Station, and that's where we ended up with. And so right now it's operating at about 430 tons on orbit with about 388 cubic meter volume, sort of like the interior volume of a 747, 747 ground. And the arrays, when it stays oriented towards the Earth, so this is actually looking at the front of the space station as it flies. and the solar rays rotate backwards in order to always track the sun. Oh, that video doesn't work, of course. So this was just recently the Crew 10 Dragon took the Crew 10 up to the station and allowed Crew 9 with Sunita and Butch to come back on the Crew 9 Dragon. The other astronauts, cosmonauts came up on the Soyuz down here. So let's see. This may speed things up because all my videos don't work. So anyway, the modules basically there's a whole set that's on the US side with the US lab and the European lab and the Japanese lab, and then there's the Russian side back here with Russian laboratory. Now the question was how to connect these two because they have different operating systems, different data systems, and that was where the pressurized mating adapter that I worked on in the early part was in order to be like a plug adapter between the two systems. And what was remarkable was that the people in Houston adopted the pressurized mating adapter as how the space shuttle would connect to the US node. So it's using a Russian design to connect the US space shuttle and US node. And recently it was been upgraded with the international docking adapter. And it's sort of encouraging to see that the Chinese are using a version of the international docking adapter. So behind the scenes, the people working in space really want to cooperate on the frontier. So we'll see if the politics allows that. So these are some of the all the parts. Every part had to be brought up individually. 27 shuttle flights. Lots of each Russian part flies up on its own and docks. So each Russian part has its own internal guidance and propulsion, whereas the parts on the US and European and Japanese side are put up and placed. And there's those pressurized mating adapters with the connectors to the for the space shuttle. So here's there you can see the adapter, the connector there for the space shuttle and bring up one module, so an attached payload. So the shuttle docks to the tunnel there. The tunnel is really small, and so you aren't going to move equipment through the little tunnel. You just move bags of water, maybe. Everything else has to come in through the outside, getting attached with the larger berthing mechanism to bring in racks, things like that. And here assembling the truss, and that's New Zealand in the background. Yeah. So here, then Soyuz brings up 3 crew, also through a very tiny hatch. And this is the cupola with the bumper shields to protect against space debris, covering up the windows. And here the open with the open windows. In an early design, we always thought that we would have this window for operations very early in the process, but actually it ended up being one of the last elements added. So all the assembly was done with video screens and robot arms. So that's what it looks like right now. The Japanese module, it started out that Japanese module was the smallest, but as the lifting capability of the space shuttle to the higher inclination orbit was reduced, all the other modules got shrunk, except the Japanese stayed the same, and so ended up being the largest module. And but it had to be launched empty, and so all the racks had to be installed on orbit. It really helped during the design to have not only the arrangement of where you plug in the modules be decided later, and also what racks you put where being decided later. So it reduced some of the constraints on the design. It allowed people to decide later to add modules on certain parts. This is on the right, they're watching a movie in one of the nodes. On the left, they're taking pictures. The New Zealand ends up being one of the favorite places to take a picture of for the astronauts. This is Auckland, so we're over here somewhere. Oh, right down here. We had several failures of imagination. We thought that we maintained a nice clean laboratory, and the reality is that after 25 years, you've been living in a lab that's been, wired, and you're really lucky if people remember exactly why things were wired that way. And so there's an entire army on the ground trying to keep track of where people put things, and they managed to lose something the size of one of these desks, and they still can't find it. Every lab ends up looking like this. The Japanese one looks a little cleaner, I think. It has, and you can see why people like to use it as a sleeping quarters is to go there. Otherwise, you're bumping into the equipment around here. There is a weekly group meal in the Russian segment. The space station is so big that, and people working on their own experiments, that oftentimes they don't see each other for so they can be working all day or a couple of days and not really see each other except for meals. And mostly U.S. astronauts are eating in the node, and they have to go over to the Russian segment. It's a special effort. But you can also see how people's faces end up being puffy and in zero gravity, and so it's real hard to read expressions, like whether or not somebody is mad at you or smiling. You can't really tell. Here's some of the sleeping compartments around the edges of the node too. There aren't enough sleeping compartments for the crew, and so people end up, one commander ended up in the Dragon vehicle. He was realized he had to clean things up in order to come home because he was using the escape vehicle that way. So some of the lessons there have been 280 astronauts and cosmonauts that visited space station, over 3,000 research experiments, and for a wide variety of different areas. On the attached payloads, there's ones that are looking up, there's ones that are looking down. The Japanese are very clever. They have their own little exposed facility out here. The Europeans recently added an exposed facility here. And so we have lots of different areas that have been worked on. There's in life sciences, the experience of the astronauts have seemed to simulate osteoporosis in a matter of a year. And there's also a very unusual genetic activity that in stem cells and even in plants that they find weak, activating all these different varied genes. There's lots of manufacturing experiments of protein crystals, fiber optic material. There's a Bose-Einstein condensate of a quantum, 100,000 atoms acting as a single quantum wave. The magnetic spectrometer has recorded events that are 200 times more powerful than the Hadron Collider. So they're getting clues about dark matter. Excuse me. So lots of different areas that have been worked on. Some of my former students ended up making a company that made 3D printers on space station. They have about 4 or 5 3D printers operating now, experimenting with metal. Let's see, there's new space technology, new companies, these solar arrays are more powerful than the old arrays, even though they're smaller. You have, and that's the scale of things with the astronauts installing the solar arrays. This is a picture from another satellite of space station. The inclination was chosen in order so that the Russians could launch to the station. And so it reduced the payload capability of the shuttle, but it added flexibility in operations. The Chinese space station is at 41 degrees. It's interesting that it covers most of the North Island, but not very much of the South Island. So it's we're right at the boundary there. This is where the space station is today, while we're talking, which would be, it's going over there. So my animation is not working, but it's you can see how they certainly monitor where the Chinese one is compared to the International Space Station. The altitude of the space station has been changed over the years from lower areas for during the shuttle assembly up to higher orbits for the solar maximum and this is the past year, and every spike is a reboost from the proton from the Progress vehicle at the back, boosting the station. That spike right there is one to avoid a space debris that's happened about 40 times during the lifetime of the station. If you don't reboost, like the Chinese Tiangong 1, after 2 years, it drops out from the drag in the upper atmosphere at 400 kilometers. The one thing that's been very consistent in space station is the operations and the around space station. If you're in elliptical orbit approaching a station, you end up with these relative motion of these loop-to-loops, and then you come on and you can rate yourself for a final connection at the very end. You can see that astronauts are tracking the loops as they approach the station. This was another video. They've gotten very good about handing off, command, switching crew, having crew assigned to different tasks, and they also have been folding in visitors, spaceflight participants that have been going to the station. It started with Dennis Tito way back in 2001. NASA didn't want him to visit, and so, but the Russians said, in the agreement, we can choose our own crew, so we're choosing this guy who paid. And but NASA said, you can't come over to the US side of the station. It was only later ones that they finally said, okay, you can come over. So Anusha, sorry. So here's Emmeline helped the first 5 spaceflight participants visit the International Space Station, helping them when they're training and going to Star City. Now these days, Axiom has been sending crews for missions, oftentimes sponsored by governments that are finding a way to get their own astronauts on board station by buying a ticket. The plan is to deorbit station in 2030, dropping it into what's called Point Nemo, which is off east of New Zealand. And so a lot of people would like to preserve station, but if you move it to a higher stable orbit, you move it into higher areas of space debris. And so you don't want debris to break it up and cause 400 tons of debris in orbit. So nobody has a good answer. The current assumption is that they're paying $800 million for this vehicle to deorbit station in 2030. So let's talk about the future stations. So there's very interesting different approaches from attached, early, big, complex. So the Axiom station is going to start with an attached module on perhaps as soon as next in 2026, next year. All these modules are under construction and test now. Then it will detach and start to add on other modules. And very quickly build up to a large volume. So we have, it's interesting that they're doing habitation 1, habitation 2, and then the laboratory. There's an agreement with the New Zealand Space Agency to fly New Zealand payloads on this. So Axiom has been going around the world and making agreements with all sorts of places for opportunities to fly. But it is something that you can say will, you can think of what your own space station payloads would be, and you can potentially get New Zealand government support. One unusual thing about Axiom is that they have this design of this full body windows, a set of windows here with the cupola, and so you can see that they're also appealing to visitors and having this experience. For the casual visitor, you'd love to have this experience. For an engineer, you're obviously really scared about these big windows. So the very different approach is the vast space. They don't have much government funding on this, but they always want to do this early. They just want to get a module up there and start using it. So they want to do a single launch and get life support from the Dragon and just have the crew visit it while they're on orbit. So they're testing their vehicle and getting ready to launch next year. They also have a plan for later on building up to something larger and trying to satisfy the needs of NASA and others, but it's a very simple space station. They're not looking at attached payloads. They're just a series of modules that are connected. They also had early ideas about a artificial gravity spinning space station, but I really don't understand the design when they showed us a tube, and it was like, are you just going to spin the tube? What are you doing? Anyway. Starlab is a consortium of all these different companies, including Airbus and Mitsubishi. They want to do a single launch of a huge volume on this Starlab, but the trick is that they have to launch on Starship. It's so big, and so they're really betting on Starship to provide this. One interesting thing is that they actually have built in a centrifuge down here inside their 8-meter volume. So they're beginning to experiment with like what length of artificial gravity will reduce some of the effects of living in microgravity on the muscles and bone and other and hearts and things like that. But it's such a small radius that you're really getting very strong effects of, if you move your head, you would really notice, getting slammed against the wall or something like that. And so they have a very elaborate, whole sets of trying to appeal to NASA doing with all the attached payloads and with the robot arm but you can see that they're really focused on satisfying the researchers on these different things. Orbital Reef from Blue Origin is a very complex proposal to build up gradually with these different modules. They're trying to do it completely independently of SpaceX. So, they launch it on New Glenn, they don't use Dragon. It's all Jeff Bezos, putting $1 billion a year into this. And so, they have, inflatable modules, for habitats. They have, laboratories, various, they've gone into lots of detailed design on this. But it's something that would build up gradually over time. They also have, the idea is that they want to keep the core livable, not cables everywhere. And then they'd have, separate out the research and they also have, all sorts of other markets they're looking at. They have a movie studio, they have they have various things for space flight participants and things like that. One is that they're looking at Sierra Nevada Dream Chaser as a cargo vehicle and potentially evolving to a human space vehicle. We don't know if Boeing is going to continue their Starliner flights. The Sierra Nevada is a real interesting vehicle. It's been going on for development for decades. It actually, the first indication was this Russian space plane experiment that was photographed by Australian intelligence. And my advisor at Langley digitized this and discovered that that the Russians had discovered a stable configuration of hypersonic reentry. And so they copied it for the NASA HL-20, which then evolved into the Sierra Nevada Dream Chaser. So this is getting ready for a flight in the third quarter this year. And so that will be just the cargo version, and then it will evolve into a piloted version. But we do need more vehicles and more options for sending crews into space. So all these vehicles have been inside the magnetic field of the Earth, underneath the Van Allen radiation belts. One interesting thing is that next week there's going to be a launch of a Dragon vehicle called Fram-2 into a polar orbit, and we'll be exploring some of these, flying above the aurora north and south, and we'll see how that goes next week. But out at the moon, there's this plan to have a lunar gateway space station at the near rectilinear halo orbit, which is a orbit like a 6.5 day orbit around the moon that stays locked facing the Earth. Back in 2022, from New Zealand, the NASA Capstone mission was launched, and that small spacecraft had been out at the moon operating continuously since then, testing out this orbit. So Lunar Gateway is planned to be built up and help support the landings of at the South Pole of the moon. This is an extension of the International Space Station Agreement. So it's NASA, Europe, Japan, and Canada. And so we have these different parts that are under construction and about to be prepared for launch. The big question is whether all the turmoil that's happening in the US is going to cancel this. We don't know. The Europeans would be really upset because there are all these international agreements, but we'll see. So another video we can skip. So the question is, if you can get a low cost launch to operate, can you get to the point where you're building big space hotels, things like that, big space habitats? There is a proposal from this one company. You can see that a little Dream Chaser on every single, and every module has its own individual escape vehicle. It's an interesting example of what you can do with a really low cost launch. This company is not the one to do it. I mean, this is like a $10 billion project, and they've raised $1 million. But it does give you an example of what you can do with these large vehicles. And the question is, what is the market for this? If you, there's one, years ago, Patrick Collins used to study all the different surveys in different countries about space tourism and, at different price levels. And he was saying that, well, right now, global tourism is a $10 trillion market. So every day, tourists around the world spend the equivalent of NASA's budget. And so if you can tap into that, it is possible to build, these large expensive things like, cruise ships that cost $1.3 billion arrive in Auckland. So it's, so he was saying that you could get to the point with 150 orbital hotels, and that was still the first 2% of the market. Now this raises a lot of sustainability concerns. Now, this is you can have your own perspective on this. I'll just give you my perspective, which is that there are certain things that I'm worried about and other things I'm not so worried about. One is that, it looks like, when you launch that you're just causing lots of greenhouse emissions. But if you add up all the launches around the world, it's just a little bit over 1 day at the Auckland airport. So it's, there's 180 flights at the airport, 254 launches in a year, and the greenhouse emissions are scaled by the size of the fuel tank. And so four Rocket Lab launches add up to one commercial flight. So I'm not, it is something to be worried about or pay attention to, but it's not as big an issue as it looks at first glance. The question is whether or not the gases emissions in the upper atmosphere are different than just emissions on the ground. And it used to be that the space shuttle with the solid boosters was really very polluting for the upper atmosphere. But the current methane and kerosene ones, maybe, I don't know if it's a big issue. You shouldn't scatter debris all over the Caribbean. That's not good. And the space debris is really tied to issues with the big constellations of satellites. The reentry of Starlink is about 1 ton per day. Natural background is 40 tons a day. So it used to be that the cost of going to orbit was very stable up here. Then SpaceX dropped it by a factor of 10. The question is, can they drop it another factor of 10 with the Starship? And if you get down to that level, you are in the realm of space tourism. So Starship is on the critical path for the lunar landing, and they're behind on their milestones. No one is releasing yet what looks like inside a crew capsule, crew accommodations for the Starship, but you can fit 50 or 100 people at once here. And the recent flight, they did a very good job for the catching the booster, but the Starship itself spun around and broke up and scattered around the Caribbean, and it was really a problem with all of these flights with emergency flight diversions. So in 2 weeks they're going to try again, and normally the FAA would be holding them until they investigated, but they're under threat from all the political factors in the U.S. But if there is a potential of going with the large numbers of flights to the moon with cargo flights, something like that. And there's even some, ULA economic studies that said that for if they start to use lunar water ice and turn it into propellant for Earth orbital operations, that they would expect they would need 1,000 people just to run the gas stations at the moon. So it's things could take off if the economics works out. This is a complex diagram that shows the delta V, that once you're in low Earth orbit, they say you're halfway to anywhere. We say geosynchronous asteroids and the moon are very similar in delta V beyond low Earth orbit. And there's $400 billion of assets in geosynchronous orbit. So you can easily picture if the economics work out to going to the asteroids or moon as being opportunities to develop the solar system. When I started first getting interested in asteroids, near-Earth asteroids, we knew about 12 of them, and we were wondering which ones would be best to visit for mining and things like that. Now we know about 38,000, and another dozen discovered every week. Big survey telescopes on the ground and in space are going to turn on in the next 2 years and really fill in the gaps. So a lot of these some of these asteroids that are being found are easier to get to than the moon in terms of energy. That's the full all the way out to the main belt and Jupiter. This is a example of some of the asteroids that have been flown by. This is a small one, Tutatis, which is, well, I was going to show it on top of Auckland there, but it doesn't show up. But the idea is that a lot of these bare rocks are just great for raw material for building, extracting and materials for building rotating space habitats, for example. So it opens up and enables the whole Jerry O'Neill space settlement concept. But it all depends on the economics, of course. This is a chart over decades of different industries going from expensive or government supported to mass produced and low cost, and air travel is back here and the question is, can human space travel do this? It's been government dominated for so long. Are we about to emerge into commercial space travel? This thing, I wanted to say that it can go quickly. This was after Charles Lindbergh flight. He took a tour of the US and he convinced all these cities to start building airports and get ready for commercial air travel. And so Chicago and San Francisco and a bunch of other airports were started at that time. My father, as a child, saw him visit in Minneapolis. And so in my father's lifetime, he saw the entire development of commercial aviation. But he would still be shocked that I ended up living in New Zealand. So it's what we take for granted as being everywhere, connected on Earth, happened really fast. And so it's possible that you folks, and maybe not me, but you folks will see this extend into the solar system. This is some of the suborbital space flights and where the human launch sites are right now. These are some of the ones that are being worked on with India and Europe. And potentially the people here in Auckland working on Neutron will make a human-rated vehicle to launch there. And so we may end up with cities on the moon, your friends on the moon. It could be a rapid expansion. But the thing to watch is to see which of these companies will succeed, and there are different approaches from attach the station, an early simple launch, a big launch waiting for Starship, and building up gradually and slowly. So that's it. Thank you.
So thank you, Eric. We've got time for questions, but we've actually got this lecture fairly booked for another hour. So those of you who need to leave now, maybe you want to get somewhere else, you want to leave, and then we'll ask some questions. Anyone with a question? We could actually also go back through it and see if we can get some of your videos to play.
Oh,
Yeah, well,
You said that Axiom has a deal with amusements. Space Institute has in mind to send on like that, or?
The only things they've arranged for at the start are two payloads that I think will go up on one of the early flights to visit station, even before the modules start arriving. But they have a long-term agreement that, you know, if New Zealand payloads are developed for the future station, there's there are opportunities there. But they just started with two simple ones.
Okay. What are those?
Yeah, one is a biological, it's a experiment, it's a equipment to for protein crystallization, basically, a biological material. And then the other one, shoot, I can't remember what the other one is. It's some kind of materials processing experiment. Yeah.
I've only heard of Space Station Freedom very little in the past. What would be in your mind the biggest difference between that and the International Space Station?
So Space Station Freedom was trying to do, you know, all by itself with US modules and then European and Japanese modules. And then having the Russians connect in, it turned out that it was really an advantage to have two redundant systems. There's times when the Russian system saved the US part and when the US part saved the Russian part. And so, and it's none of the new space stations have this redundancy. So, it was also interesting that as Space Station Freedom was being developed, when the Russians came in, there was NASA people, you know, sort of whispered that they realized that they had forgotten a lot about space station operations in 15, 20 years since Skylab, and that they were really glad that the Russians were there to share their expertise. And so, but the Russian parts are very early and old, and you know, and there are cracks on the service module that are unexplained, and the Russians, you know, so far have only agreed to support the space station through the year 2028, not 2030. They're expected to agree to the last couple of years, but it's I don't know what would happen if the Russians said, okay, we're not going to supply it anymore, you know, like that kind of thing. But it's really complicated.
In terms of the deorbiting the ISS, given that it's modular, presumably you could modularly separate it off and bring it down in different stages or keep different stages up there. And given that we send all that mass up there, wouldn't we want to keep it? So if there's some modules that you would definitely want to get rid of, or some pieces you say, actually, we should keep those.
Yeah.
Any suggestions?
Yeah, there's they were looking at, you know, like what are some of the, especially some of the newer modules, you know, it would be really nice to keep them. And there's an opportunity on Axiom to attach some of these modules, but about all they've figured out so far is the logistics module that they use as storage, the MPLM, that will probably be moved to Axiom. But the other ones are so interconnected with their power thermal fluids. gets more complicated to separate them off. There is a lot of interest in, you know, even the Smithsonian has been asking for, please return parts of the space station. But since the shuttle has been retired, there's no vehicle that can designed to return that much mass on reentry, and so they would love to use these different parts, but it looks really challenging, and NASA's put all the documents about the analysis, and now please you know, tell us what is possible, but it looks really tricky to try to save parts of it, and as soon as you you know, put it in like uncrewed and in some higher orbit, you're responsible for what happens after that, and so that's a problem with the something that big.
First of all, I'd like to say your involvement with the ISS is pretty fascinating, extremely cool. I was wondering, would you say New Zealand's incorporation into the space industry would be as big as maybe America or China?
I think the best contribution is really in niche specific areas that, you know, really innovative solutions on specific areas like Xenos, superconducting magnetic torquers and things like that. So it's really hard to compete on a big industrial scale with all these different areas. I mean, you know, even most of these commercial stations are contracting with Italy to build their modules. Italy has gotten very good about building pressurized modules, and so a lot of the space industry is very global and looks for opportunities for components, you know, around the world, and so you sort of have to pick and choose which components you want to make. But there is a attitude that, you know, expect these things, these commercial stations, somebody will have a commercial station. Because it's commercial, it actually, you can get your products and support in there faster, you know, through the initial agreements. So like right now, all the astronauts are wearing New Zealand wool, you know, for their uniforms. They're eating New Zealand peanut butter. They chose that as and it's like these early, you know, really specialized things, but they you know, one of the attitudes is that somebody else is going to build the station, but they need to fill it up with all the systems that are going to support everybody. And my friend who's running Orbital Reef he said that he was spending a lot of time talking to celebrity chefs about how to take care of high-end passengers with specialized food. So, yeah.
What was the reason for deorbiting the International Space Station? Was it just cost, or is it more like each government wanting their own space station?
It's basically who's going to be responsible, and if you just let it drop randomly, parts will survive down to the ground, and it's 400 tons raining from the sky, and so they have to have this vehicle that gradually brings it down within striking distance, and then burns like crazy to drive it into that spot in the Pacific.
His question is like, why deorbit?
Why deorbit? Okay, it's right now it's an ongoing expense to maintain that level of operations that are right now, and with crew on board that are flying the vehicle. And that if you stop doing that, if you stop sending crew, then the station becomes uncontrolled and more of a chance of it running into pieces and just breaking apart, like if I drop the Lego model here. It's a lot of it is the level of responsibility. You have to take care of it.
I'm just gonna say it's what is it, 28 tons of fuel that has to burn every year to stay up there?
Yeah, I don't know the number.
I can't remember the number.
that
but
would-
something like that.
That would be something like that. And the and every time you do an impulse, it ends up sending shocks through the whole system, so it's been going on 25 years of shocks like that, and so it's right at the edge of its design life. Yeah, they don't want to see what happens when parts start failing. But it is unfortunate that, I mean, the Mir station is very similar. Mir was actually leased by a friend of ours, or purchased. It was going to turn into a commercial station, but then NASA was pressuring the Russians to not try to operate two stations at the same time and to deorbit Mir. It was going to have an electrodynamic tether to put it into a higher orbit, and but it was yeah, it was kind of unfortunate that the early commercial space station of Mir was killed by a certain pressure to eliminate it. That was also dropped into the same place in Pacific. Yeah.
So some of the stuff we've been reading, well, I've been reading up about ISS is the degradation of the materials on the exterior. You know, you've got active oxygen particles bombarding it. You've got planes and bullets basically striking it. But you know, presumably there's some material degradation, and they've got to take into account why they leave all the things. But the new ones, you know, they're choosing materials, what new materials available. Are they looking at variations? Are they sticking to aluminium and stainless steel and
yeah, and each one is different. They're pretty much for the modules, I think they're staying pretty much with aluminum. It's
About max space.
yeah, so they are testing these inflatable modules. That was demonstrated with Bigelow Aerospace attached payload on station, but you know the inflatable ones end up with, you know, basically have a layer of Kevlar in there that makes them as strong as the other modules. But yeah, it's I don't know the exact details, but it's a lot of them are using the same traditional.
some of the early stuff was some stainless steel and with
Yeah,
Starships using. Are they likely to use stainless steel again, or is it?
I don't know. Yeah, I don't know. SpaceX has gone big on stainless steel. A lot of these are traditional aluminum, and oftentimes for the debris impacts, they have a bumper of like a little layer 20 centimeters out that will create a vaporize. Yeah, so it impacts, vaporizes, spreads out the explosion.
So it's my understanding that like the white arrays on the ISS and the Axiom, they're like heat sinks.
Yeah, that's right. They're thermal radiators. Yeah.
I was just curious, what do they cool, like what's the advantage of having them externally mounted in those arrays?
Yeah, yeah, I didn't complete this model, but yeah, you're talking about these back here with they try to keep them edge on to the sun, you know, keep them in shade. That the one thing in space is there's no air to blow around and cool the station, and so the station will overheat if you with all the electronics inside, and so you have to keep and they actually are pumping fluid through these out to the radiators out here to radiate heat and then bring the cool fluid back. And so the only way you can get rid of heat on these space stations is radiation through. So every for the Russian ones, you know, each Russian module has its own radiator. For the US, for the ISS, the big radiators are out here at the back, and you know, they don't have to be perfectly edge onto the sun, but they try to generally be edge on. But that thermal control was always a big issue for all these stations.
Future stations, are they all gonna be much the same altitude at 400 kilometers or?
Yeah,
variable?
definitely, Axiom starts at the ISS at 51.6. And so it will stay in the same orbit inclination, but gradually the orbits will drift apart through precession. Each of these stations, in order to appeal to the NASA requirements, they keep quoting 51.6 as inclination, so they're all doing a similar element. But I wouldn't be surprised if they end up changing to a lower inclination, because you can get a lot more mass from Florida if you launch to 28.5 degrees due east.
And also in terms of kilometers up altitude?
Yeah, they're
higher.
very similar to in the 400 kilometer altitude. And so as long as you're separated by a few kilometers, then it's okay, and we're gonna pay attention to how these the orbit motions are. The Starlink ones are up at 505 or something like that kilometers.
Are the solar panels also liquid cooled, or are they just left as is?
They're just straight arrays, and with different technology, most of these arrays are, they're actually, they've evolved somewhat, but they haven't changed a great deal. It's kind of funny that they're almost translucent, so that when you see from the behind the sun, they look orange, and that's why in Lego model they stuck some orange pieces back here to simulate that. Yeah.
So in your engineering design career on this ISS, what do you think was the trickiest thing to work with in terms of, maybe is it the teamwork or is it some engineering detail?
I think it was the teamwork and we would go a long time studying various issues, and then there would be a Tiger team of 90 days to look at to do a redesign. And I ended up arguing with the guy who became the NASA administrator quite a bit about what the inclination change for Russia was due to communications and things like that. I proposed the module arrangement that was used, but it was rejected, and then Houston proposed it again and it was adopted. It was kind of crazy because the requirements were not very clear. I mean, it's like when we were finally given the cost numbers, and I just did an exercise. I deleted all the hardware, and we were still over budget. So I was like, okay, these the cost numbers that really help. And we were asking, like, okay, if you want to design the space station, optimize it, what are you designing it for? And we said, what are the experiments that are important for the station? And so we got the experiment list, and it was sorted by congressional district. And you can sort of see the NASA headquarters point of view on this. It's like, they just wanted to spread a political support around.
So it's very much a political exercise.
Yeah, it was very tricky. And every time that I was told that I couldn't work on something, I would say, but I've got a student that wants to work on this. And so I would play the game and make sure that I could work on anything I wanted to. So it was, but it was very interesting because you really felt that, you could, we would have loved to have a Lego model at the time, and playing with different parts and things like that. At the time, I was making a Macintosh drawings that ended up being guiding the design of the space station. It was just really a strange feeling to have, know that 10,000 people are out there and waiting for how you put together your chart and tell them what to do. But at one time with the Russians, I had made, little Soyuz vehicles in my drawings, and I didn't make a Salyut or a Miracore. That was when the negotiations started with the Russians. Instead, one of the other NASA people grabbed one of my drawings and just stretched a Soyuz and called it a Salyut. And the Russians were looking at it like, you want us to build a big Soyuz? So anyway, it was an exciting time and so it's really interesting to see that, these companies are in the same process right now, that Axiom has gone through several changes in their configuration. We visited their factory in Houston a few months ago, and it's really interesting to see all the work being done in different pieces. And the same with all these others, that to know that these are going on in parallel. Yeah.
What are the different challenges between, let's say, the Lunar Gateway and the stations in lower orbit? Is there, you swap and change, or does the Lunar Gateway require specific tech for that?
Yeah, the Lunar Gateway, well, for one, it's going to be sitting in the sun. It very rarely gets in the shadow of the moon. It's always going to be oriented towards the sun, flying inertially. It's out there in the radiation environment. The big issue for humans is that whether or not you get a solar flare or coronal mass ejection, you get about 8 hours of warning before you have to seek shelter. Here's the gateway in the same scale as the space station, so it's really tiny. If your astronauts are sitting in the module, they're sitting knee to knee, and it's really difficult to get logistics all the way out to the moon. In fact, the launch from New Zealand, the Rocket Lab Electron launching Capstone mission was intended to demonstrate that you could deliver something out to the gateway orbit from a low-cost small launch vehicle. So who knows? New Zealand might end up being a supply for Lunar Gateway. Another big problem is that Lunar Gateway is designed. They always show this vehicle here, which is a standard NASA reference landing vehicle, but this vehicle is actually replaced by the Starship Human Landing System, which is a giant monster vehicle. And so so if Starship docks to Lunar Gateway, it actually destabilizes you have to fly it from the Starship, not from Lunar Gateway. It's really going to be surprising if we continue with the current architecture with Orion. Orion is like a SUV that you take out to the moon, and then you dock with the Starship Human Landing System, which is like a 3-bedroom house that will land on the moon. So we'll see if that continues as planned, but it's on NASA schedule. It happens in 2 years. Well, I'm not sure if I believe that, but
Yeah, I think
yeah.
probably end it there. Another hand, round of applause for her.